Good morning, everyone. Andrew Fonseca here with Miovision. Just jumping on quickly. I know we're expecting a few more attendees, so just going to hold off for a couple more minutes here until we see a few more people trickle in, and then we will get going. Thank you. Okay, excellent. So we will start the webinar now. We'll get Mike from OSS to kind of kick us off, and then we'll get the show on the road.
All right. Can you hear me?
Yes, I can.
Yeah, we can.
Excellent. Thanks, Andrew. Welcome everybody to the Ocean State Signal vendor series. This is the next in a line of quite a few lately. And today we have Miovision. We'll be talking about real-time data, and we've also got a special guest, Chris Cassani from the City of Quincy. That's going to talk about how the City of Quincy's been leveraging the Miovision platform to manage their traffic signals. And with further ado, I'll hand it over to Ian to get us kicked off.
Thanks a lot, Mike. Good morning, everyone. Thanks for joining us this morning. My name's Ian Davis. I'm an account executive with Miovision, and along with Andrew Fonseca, who's also on the call, another account executive. We both handle the New England market and work very closely with Mike and the team at Ocean State Signal. They're our valued partner in New England. Also on our panel today, as Mike already mentioned, we have Chris Cassani, Director of Traffic, Parking and Lights with the City of Quincy, where we have a very significant traffic link deployment. And also two guests from Miovision, Sajjad Sharavi and Olivia Babcock from our Traffic Engineering Department. I will be fielding questions during and after the call. If you just click on the chat button on your screen, I'll record those questions and we'll get to them at the end of the call. So once again, thank you very much. And with no further ado, I'll pass it over to my colleague, Andrew Fonseca.
Perfect. Thanks, Ian. I will just share my screen here. Can everybody see my screen?
I don't think yet. There, yeah, now we can, Andrew.
Should be good to go. Excellent, perfect, thank you. So again, thank you everybody for attending today. I know this is the second part of a series that we've done with Ocean State. The first was more around our detection product itself and the more of the actuation detection, installation, and hardware component of our product. However, today we're going to focus a little bit more on the data side of the platform. And not only the data we can generate, but how agencies are using it, and also how we're looking at innovating on top of that data to make that data more impactful and more insightful to our customers. So first thing we're going to go over is a quick hardware recap, just so everyone on the call today, which is a small but mighty group, will be able to understand what our hardware looks like, kind of what parts do what. Then we'll jump into the fundamental technology that we use to actually generate data. So a lot of our video analytics, the ability to count 24/7 and how we've built that up. And then we'll jump in, Sajad will take over, going to the ATSPMs. So looking at automated traffic signal performance measures that are generated at the intersection, and really the philosophy that Miovision has around them, and what you can do with them and why you would do that. Chris Cassani from Quincy will step in and talk a little bit about his experience with both our hardware and the data it generates. And then we also have some interesting data from one of the MassDOT districts that we generated. So we'll kind of walk through some of the data that we were able to pull there. And then obviously, please feel free to ask any questions throughout. With a small group like this, it's easy to make it a little more interactive at the end and have a conversation. So looking forward to that. So first and foremost, want to thank Mike and everyone over at Ocean State. They're our distributor in the New England territory exclusively. So we work with them on the sales front. They support on the installation and configuration side of the business, also with training and any type of technical support alongside Miovision. We also have our own internal technical support team that can support Ocean State and customers directly. So we have a very strong united front from a support side, and I think that that's key to Miovision and Ocean State's success in the territory. So a quick product overview. Couple of pieces of hardware here. We have our SmartLink, our SmartSense, and our SmartView. Won't spend too much time here, but essentially the way you can look at it is the SmartLink is a communications hub. This could plug into the controller cabinet, pull a bunch of data, kind of plug into other devices there, like the MMU, backup batteries, etc. I'll talk a little bit more about that. So that is our communication. That's what takes our data, pulls it up into the cloud, and then into our web-based platform. I'll skip the middle one. The SmartView is a 360-degree camera. It could be used for strictly remote monitoring, tapping into the intersection, seeing what's going on in real time. We also have the ability to store up to a week of video should an agency want to. We default that to off, but that is also something we can do. SmartSense device in the middle, this is the brains of the device. This is what really does all of our roadside analysis. This is where machine learning is built into, and this is what provides all the video analytics. So the ability to count vehicles, etc., which I'll talk about briefly. But all of this together is what comprises our Traffic Link platform. That being said, the SmartLink itself can be used on its own. So the SmartLink, looking at communications and looking at remote access, one of Miovision's differentiators is we've built this with built-in LTE communications to make it very turnkey and simple for agencies to connect traffic signals and bring that data back either onto our platform or to an existing central management system. But no time more than now are agencies coming back and wanting to leverage those benefits just due to the pandemic that we're in, and the ability to provide more remote working conditions for both field staff as well as internally for traffic engineers and planners to understand what's actually going on in the field and becoming more data driven. This device can do that. So I'm not going to go through everything here, but the ability to plug into backup batteries and provide alerts on that front, the ability to integrate with different central management systems. I know a lot of the DOTs run a tactic software. We can pull all that data into that software as well. Another big one is existing adaptive systems. So this device does support ATSPMs, which can feed its data into any type of adaptive system that will allow third-party kind of information to come into it. And then last but not least, we can not only integrate with existing detection, whether it's pucks, loops, or anything that's out in the field today to pull ATSPMs together, we can also integrate with existing communications. So whether an agency has fiber, whether it has point-to-point radio, we can integrate with that and pull all that data back. So that's the smart link, which can be used on its own for communications and kind of performance measures. The other piece is the smart sense. So with this device, kind of all of them together, we're able to use our AI to do a couple of things. One is obviously fully actuating an intersection. But then we can also do 24/7 multimodal turning movement counts. That includes pedestrians and bicyclists. We'll get into a little bit of what that data looks like and how agencies could use more of a longer period of data for their benefit. So that's kind of the two different separate pieces. One is the video analytics side of it, which is the camera and the smart sense, and the other piece is the ATS PMs and communications piece, which is the smart link up here. Last is the camera. Just a couple of quick snapshots below. These are actually snapshots from Quincy. So because of our AI, you don't need to mask anything out. And the reason why I bring that up is just the ability for the AI to know what a vehicle is, what a pedestrian is, where they are at the intersection becomes crucial in some of the stuff that we're building. So we'll talk a little bit about that as well. So the full architecture, just so everyone has a grasp of that, we plug into the cabinet, fairly straightforward. We can plug in a couple of ways. We won't get too deep into the technical, but we can plug in SDLC and TCP to a controller. Both devices go in the cabinet. An antenna goes on top of the cabinet, which provides 4G LTE communications, as well as other things like a traffic probe for travel time, Wi-Fi MAC address, as well as time syncing. The camera mounts at the intersection, fairly straightforward, pulls the video into the device, runs through the controller cabinet through our devices in the cabinet. We take that data up into the cloud, and then we can do one of two things or both. We can take that data and pull it into our web-based platform, and we can pull that data into an existing software system. And that could be anything from a central management system, or pulling in our RTSP feed as well into a video surveillance system. And then sitting on top of that, we have open APIs for our data. So for travel time and turning movement counts. So you can technically pull that data directly from our device into any other platform that a city chooses to. So for the folks on the line that have not heard of our Scout, Miovision has been in the traffic data collection industry for a long time. I talked about this on the previous webinar. Over 10 years. Through that time, we've collected 7 billion vehicles and over, close to a billion cyclists and pedestrians. A lot of the larger data collectors in the New England area use our equipment to facilitate turning movement counts, to model their synchro analysis. So a lot of the data that goes to an engineering firm or to a city indirectly comes from Miovision. I think it's about 60 to 65% of the counts done in North America flow through us. So essentially, we're able to take that data set and build up an AI to do this in real time at the intersection. So if we look at a couple of the views down here, this slide is traditionally to look at how we can actuate in different weather conditions. But I think looking at it, it also shows how we're capturing vehicles and we're tracking them through the movements. So when a box gets drawn around one of these vehicles, what our system's doing is it's not looking at the size of it. It's not looking at where it entered and where it exited for a turning movement count. And you can see these purple lines here, kind of the layout of the turning movement count and tracking vehicles through them. But what we're actually doing is the system's identifying what the characteristics of that vehicle is. So is that a car? Is that a bus? Is that an articulated truck? Is that a pedestrian? Is that a bicyclist? So the system is actually doing that thinking based on all the modeling, using all the data that we were able to feed in through our system to kind of train it to understand what these different things are. So not only can we do counting, but we can also address different weather conditions, different than, say, some traditional video detection that's out there. But enough about the video detection. It's more around the data today. So what kind of data we can generate. So there's 3 different levels of data that we can generate. One is the continuous counts. So the ability to, as I mentioned a few times, as you can see on the top left corner, large group of pedestrians at the bottom right, heavy groups of pedestrians, vehicles by classification, and generate those 24/7. The other is safety. So safety is a data set that we're hearing more and more that agencies are looking for, and you know, going from using crash analysis tables from 10 years ago to doing a full conflict analysis report, there's got to be something in the middle there that actually looks at pedestrian and vehicular behavior and act more as a surrogate safety measure. And we've recently launched 2 of those. One, which is our red light running metric, which tracks vehicles, and we'll show an example of that and kind of where red light runners are happening, how often it's happening, etc. And as well as pedestrian compliance. So similar metric to understand how pedestrians are using the crosswalk. Are they crossing when they should be? Are they pushing the push button as well? Because we can read that. So some interesting data around that we're continuously planning to build off of. And then lastly is the automated traffic signal performance measures. So using both stop bar and upstream detection, we can pull an array of metrics in that can help cities and engineering firms and consultants to cities, help them use that data to address traffic congestion and safety. So I think this is my last slide here. What's extremely important is also how we can innovate and how we can future-proof investments that cities make in hardware. So, you know, Miovision looks at remote updates and continuous learning as a key differentiator as well, in the sense that once we install something in the cabinet, we can pull a lot of that data up to the cloud, and we can retrain data. So what that means is if Chris has a fairly large deployment in Quincy, but if in Vermont there's a snowstorm and we're having issues either actuating or counting, we can take that data, we can train it, we can validate and test it, so we can run it through our AI, make sure that it works, and then we can push that out to all of our customers, including Chris. So what that means is all of our customers kind of get to grow and get to learn from the environments around them. And we push that out over the air. So at no time does anyone ever physically need to go to the intersection and plug in a USB to update their software. It's not stagnant in that sense. We're continuously improving it. So I probably went a little bit longer than I wanted to, but we did start a little bit late. But that is kind of top to bottom our hardware, and then a kind of our philosophy on how we support that hardware in the field and the data we can generate. I will now pass this over to Sajjad. Sajjad will jump in, introduce himself, and start talking a little bit more about the data.
Hi everyone, this is Sajjad, the traffic engineer at Miovision. I'm also a product manager on the traffic analytics front. I'm just trying to figure out to share my screen here. Okay, there we go. Are you able to see my screen?
Yep, we can see your screen. Just got to maximize it, but yep. Oh no, that's on my end. Yeah, we're good.
Okay, awesome. Yeah, so here we're going to talk about sort of the data side of things. As Andrew mentioned, the connectivity, all the components that you're talking about. This really opens the opportunity to sort of to an incredible amount of data that will help, with the help of our software, it can help cities sort of turn that into impact. So the idea here is to let's leverage existing infrastructure. Let's tap into the existing infrastructure and through sort of clever ways being able to combine different sources of data that provides us a very high resolution view of the performance at the intersections and the network. So it really helps with first of all, continuous measurement of the performance of roadways. It can also be accessed from sort of everywhere because it's cloud-based and sort of the data is being collected and aggregated and presented in the software. And one of the main use cases for that is being one step ahead of citizen complaints. So being able to sort of proactively manage the traffic network and through the data being able to identify inefficiencies before it turns into a serious issue or a complaint. And really the idea is to be able to maximize network efficiency and reducing the need for costly road widening projects. So maximizing the efficiency and maximizing what we can get out of the existing infrastructure as opposed to needing to add. And if there's a need to add it, using the data to be able to inform that. So the conventional approach towards signal retiming and signal management in general has been, okay, we're going to measure demand for a short amount of time. We're going to model traffic in a type of software like Synchro, for example. We're going to evaluate and then improve and optimize based on that. And we're going to put that in the field for a while without really knowing how that's performing. But the ATSPM approach is more about measuring performance directly. So let's go in. So again, by tapping into the infrastructure, we're measuring performance directly based on the user's experience of the roadway. We evaluate it, we improve and optimize. And then the good thing is that there's a feedback loop there. So as soon as something is implemented, a change is made, you can quickly go back to the performance measures and evaluate what that means in terms of performance. So we advocate for the idea of healthy signalized intersections and corridors, and the whole idea is that even if there's a major signal retiming that happens, and we're happy with that, things happen along the way. So as time is passing by, detectors may fail, or there might be, for example, clock drift issues, some operational problems that happen, or there might be just change of pattern, changing people's behavior, or changing travel patterns due to new developments or other reasons. And then the whole idea is to be able to sort of keep ahead of these changes and make incremental changes to reduce the need for major signal retimings and keep the health of those intersections nice, optimal most of the time. And the data can really help with maintaining that health at four levels, and that's on the maintenance level, so sort of just making sure the infrastructure is working, detector that's broken, regardless of how good an optimized plan is. If there's a broken detector out in the field, that would impact the the other layers, so operational or optimization. So even if I have the best timing plan in the world, it's going to be problematic, or it's not going to really achieve its maximum efficiency if there's a broken detector. So that's the maintenance level. There's the operational level, just making sure that things are running as they should from an operations perspective. So just to give you an example, I've seen this a lot of times where one or two intersections along a corridor actually operating on a different cycle length, even though the aim was to coordinate those intersections. So unknown for a long time. A couple of the intersections are operating on a completely different cycle length, and that is sort of an operational issue that although the idea was to be able to like optimize and coordinate, but due to some issue, it's not being implemented properly and it's causing issues. So we need to make sure we are fixing that issue before we talk about optimizing the offset, because the offset doesn't matter in that case if the cycle lengths don't align. The optimization layer, for sure, that's the split cycles and offsets and time of day plans. It helps with that, and Olivia would walk you through a couple of examples there. And ultimately safety. So this is another area that we're actively working on, and we have a couple of metrics that we'll get into in a little bit. Is that okay? We're making sure things are working properly on those three levels, but to also be able to assess the performance of the intersections against the safety objectives as well too. So where do these performance measures come from? There's, depending on the type of detection that you have available in the field. So again, this is not tied to our hardware. We're tapping into the current technology that you have at the field. So if you have loop detectors, if you have radar, any type of technology, POX, we're reading that and we can generate the performance measures out of that. So advanced detection, if you have advanced detectors, so usually 300, 400 feet away from the intersection, that would enable a number of performance measures. for example, arrivals on red and green. So by associating the arrival of vehicle on an advanced detector with the signal status, we can provide information on the number of vehicles that you have arriving on green or arriving on red, which indicates the level of progression or the quality of progression. Another type of detection that's used is stop bar detector. So using a stop bar detector is used to evaluate the quality, the performance of each individual intersection and the level of saturation that it's experiencing. So using stop bar detection, we can identify and we visualize that how many cycles, for example, are experiencing cycle failures where they're not able to push through the entire queue in one cycle. And then there's other data, for example, the signal phasing data, the pedestrian push button, the preempt data. All of this data is, we're reading that because it's coming off from the controller. And one way or another, so either the data on itself or in combination with detector data is presented in order to give you a very clear view, a high resolution 24/7 view of what's happening out in the field. So again, this is more about like what type of performance measures we're generating out of that. So you can see that there's quite a few performance measures that could either come from the signal controller directly. It could be a combination of signal controller data with the detector activations, as we talked about. So the more detection that you have, the more sort of performance measures that you will have access to. Other data like the pedestrian push button is another data that's being used, and travel time, which sort of comes from our hardware, where we take that and we convert it into a variety of different performance measures, including speed, congestion scan, providing travel time reliability, and a variety of indexes there to help you with your analysis of the performance of the intersections. So just so you know, so the data that's coming from the signal controller and the detector, these are sort of 100% sample size. So we're achieving 100% sample size that we're getting from the controller. Our travel time data, we've done some analyses on it in an urban environment, and we have seen 16% sample size or 16% match rate. So we were able to get 16% of the total number of vehicles that, for example, are going from point A to B. And that is more than enough for a statistically valid average travel time reading. So so I know that there might be a lot of vendors that sort of talk about AT-SPMs, but really the thing that really matters is that what's next for AT-SPMs. And there's two different areas that we are sort of expanding on top of what is currently available. And the first one is leveraging computer vision. So as Andrew mentioned, computer vision technology, it opens a completely new world in developing performance measures and intelligence on top of this data for modes of traffic or instances that traditional detection technologies just cannot see. So if you want to see pedestrians, if you want to generate performance measures around, for example, red light runners, bicyclists, also different modes of traffic, just beyond the typical traditional technology, detection technology, this is what is required in order to see that. And it enables a whole new opportunity. Olivia will walk you through a couple of examples there. We've generated 2 performance measures to this point. We're using computer vision technology and the signal status data and built on top of AT-SPMs. One is red light running. So by detecting sort of the vehicles as they're passing through an intersection and somewhere where they're in the middle of the intersection, we know that we've classified the vehicle, we've tracked it, and we assign that and we correlate that with the signal status, and we tell the user, okay, this is the number of vehicles that are passing on red, how deep in the red they are, and sort of how frequent that's happening with the exact timestamp. So going back to the video and being able to evaluate and assess it. And pedestrian compliance as well too. So we have pedestrians, we're classifying them, sort of tracking them as they're going through the intersection, through the crosswalk. And by correlating that with the signal status, we can exactly tell how many pedestrians are being signal compliant and how many aren't. But this is just the start of this. There's a whole world of different types of applications that that computer vision really enables. And then another part for what's next for ATS PMs is really the way that we see it is that it sort of says data, intelligence, optimization, automation is the value chain of the data. Most of the vendors are in the data space, so there's a bunch of data coming, they aggregate, they present it, but no one's really translating that into traffic engineering terms that could really help the user turn that into an actual impact. So they're allowing the user to sort of go in and figure that out themselves. But something that we are actively working on is to be able to add that level of intelligence on top of the data, automatically identify problems and issues that are happening in the network, and being able to visualize that in a very simple way and enable you to investigate that. So finding those needles in a haystack as opposed to sort of just throwing you into a bunch of data and telling you to figure out, but we actually doing the hard work for you and allowing you to do the solutioning as opposed to spending your time on figuring out the problem. So stay tuned for this. Hopefully this will be coming out soon. So I will stop here and I will pass it over to Chris.
Great. Thank you very much, and thank you for inviting me to present. My name is Chris Cassani. I'm the Director of Traffic, Parking, Alarm, and Lighting in Quincy, Massachusetts. And we've been working with Miovision for a little over 2 years at this point right now. Really been delighted with the product and have been working, hand in glove with the team at Miovision to talk about a number of different things. About how we use it and how we use the data and how we kind of see the product being beneficial to our community. So we have a little bit over 30 intersections deployed with the full Miovision suite. We have another nearly dozen intersections where we're going to be adding the SmartLink, some of those tools to the tool belt in the city. And what we've found really is that it's a essential product for our adaptive network of signals that we have. So we have 22 intersections that are integrated with the SureTrack platform by RapidFlow. And it goes without saying, in an adaptive network with predictive analytics, that having the ability to see in real time what's going on, process that information in real time so that a system like SureTrack can operate, like I said, it goes without saying that that's essential. The tool, though, with Miovision that we find so useful is its ability in the adaptive network, certainly, but apart from the adaptive network, one of the things that we find incredibly valuable is the ability to bring communications to sort of a communications desert. And we're a pretty big city, we're a pretty old city, but we do have a pretty robust fiber optic network. We have expanded our fiber optic network in order to make some of our adaptive projects feasible, but it's not always feasible or cost effective to do something like that. So, one of the things we've been able to do is we've been able to bring Miovision into places that have never had any detection. Now, in a more modern city, it's entirely possible that you wouldn't have any intersections like that. Although you think of, very super modern cities that just rely on a very simple, two-phase type of pre-timed situation. What we have found in Quincy is that if we do this, we're getting into intersections that have a number of flaws. It might be 12-foot post-mounted traffic heads with no handholds. You could think of installing loops in a situation like that. It's sort of the easiest, in theory, way of doing things. Once you start having to excavate the roadway, for example, that cost-benefit analysis really skews the other way. And you start looking at different options. We've been working hand in glove with the folks at Ocean State and, with Miovision, obviously, to figure out ways of getting through that hump or getting over that hump. So we have a few intersections where no detection had ever been present. We didn't have any handholds. We would have had to rip apart the roadway. And what we did was we were able to install, a 20-foot traffic post, mount the shepherd's hook for the Miovision camera on top of the 20-foot post, get the camera in. In some cases, we've been able to pipe the Cat5 underground, and that has worked out fairly well. But in other cases, we've said, geez, there is no conduit, or the conduit's crushed. We want to avoid excavating the roadway. So we've, strung the Cat5 overhead into the cabinet, and no one is any the wiser. And all of a sudden, instead of having zero detection, you have the best detection you really could possibly have. So that is something that is just not really available through other platforms. Obviously, the single fisheye lens is hugely beneficial because you only have one run of cable, but you get that extra value. You get the ability to even expand your adaptive network through the data you're collecting via the Miovision platform. And I think it's hugely beneficial, the level of cooperation that you have really between Miovision and a company like RapidFlow in their SureTrack platform. One thing I wanted to comment on too for us that has been tremendously beneficial is, when COVID hit, when the lockdowns hit, there was a great value in the data we were collecting that just it was very eye-opening. Wow, look at how low traffic has gone. Look at the cuts, look at the 50% reduction in vehicular traffic. No other platform, though, would really give you the idea that there was an 80% reduction in some cases in pedestrian traffic at very, very, very busy pedestrian corridors. So, it's very interesting to get that data. It's been interesting to watch how things rebounded, toward the latter part of April and into May and June. And, now here we are in somewhat of a new normal for traffic, and who knows how things will change. One of the things we've noticed, and I think that, I don't want to speak for the District 5 commentary after me here, but what we have noticed is that certain times of the day are every bit as busy as they used to be. It's just they're different times of the day than they used to be. So going back to the whole, the adaptive world, what is so interesting about something like this, going to an adaptive world versus a pre-timed world or even a coordinated world, is when you have those sort of unexpected shifts in demand out on the road, you really need to be able to react to those in real time. So in an adaptive setting, there's this idea that, hey, we have this algorithm, and I don't want to speak ill of anyone's, technological bona fides, certainly, but you can't just rely on the technology to do everything without any human oversight. So the artificial intelligence that we have is tremendous, but one thing that we have learned is that it's not a silver bullet or a panacea to make everything work perfectly. In a world of predictive analytics, if you're not predicting things perfectly, if you're not counting everything perfectly, or if there is any type of glitch or data change that needs to be made or programming change that needs to be made, you need to have the ability to see that and make those changes in real time. So one of the things that we've found with the Miovision platform is that level of seeing the landscape, understanding the landscape, and actually I would say to a certain extent, learning about the peripheral environment is incredibly valuable. I think of older fixed camera deployments, which we do still have in the city in a couple of instances. The camera points at the traffic and you count, you see the cars moving, and that's really it. It doesn't really tell much of a story. It doesn't really help you to understand, oh, there's a park there. There's a new park there. There's a new park that has lots of people showing up at it and no one ever showed up there before, or whatever the case may be. It doesn't help you understand how busy a supermarket can get during a COVID lockdown at 10:30 in the morning when you never could have seen that. Where the Miovision platform, through the 360-degree view, you can see those things. And those are actually really, really important things to learn. So it does add that level of context to a traffic count that you don't get through just reporting numbers on a spreadsheet. But it also allows you to have that constant level of checking your data to make sure that any assumption you made last week is still a valid assumption this week. And as we all know, in this COVID world, I mean, things are changing very, very quickly. This is giving us the ability to really understand, how those changes are happening, when they're happening, and it gives us the ability to pivot and adjust. It also gave my team the ability to go fully remote instantaneously. So having the ability to dial into a traffic controller has been, remotely through the Miovision platform has been invaluable to us. It's sort of a funny story, and I don't want to speak for Mike Wozleski, who's on the line. In the first part of this, when there was the fear of surface, contracting the disease via surfaces, there was an effort around the area to go to make all pedestrian crossings automatically actuated. And I think that there was a story in the Boston Globe from the town of Brookline where it was like, hey, this is how we're doing this to help people not have to touch anything. I think 2 days later, they had to back off of that because everybody was furious that they had to sit at an intersection to wait for an exclusive ped cycle to come. But it gave us the ability to do things like that. So having that level of observation and then the ability to change things, to take things out of coordination remotely, to not have to go to the cabinet, incredibly important. And it also allows, in a situation where you have a widely varied workforce, I mean, realistically, with something like Miovision, you could have a traffic engineer, as we do obviously between Canada and the United States, but you could have someone in a completely different time zone, an 8-hour flight away, learning about your city and being able to participate in your traffic discussion, helping you. We don't have that yet, but we do have people who are out in California who have never come to Quincy, work with SureTrack, for example. So it makes that possible. And what it really allows, I guess, is the best and the brightest at these different firms to work, and then for them to integrate with us. And it allows us, I think, to speak somewhat fluently about an intersection that's 3,000 miles away from a programmer in San Francisco, but they get it. They understand what the peripheral situation is at it. And I think that allows them to say, oh, okay, I understand. There's a supermarket there, disappearing, reappearing vehicles, that whole dynamic in that adaptive platform. And that really only exists through the Miovision, suite. So again, it makes SureTrack possible. And I would also just say, like I said, to reemphasize that in an adaptive world, you cannot assume that everything is perfectly fine, because there are so many different things that can happen to make the incoming and outgoing data change. And I think that we now are able to diagnose through Miovision, we're able to diagnose any potential issues and address them in real time, whereas that would really be impossible in a wide deployment of something like this if you couldn't see it remotely. I think you would just sort of assume everything is okay, but in reality, you're not getting those benefits. So things like split failure and some of the other metrics that Miovision's added and is constantly adding allow us to do a better job. I would also just add, there's been a great benefit with our police department through deploying Miovision. It isn't a security camera function. However, the level of quality in the video feed certainly allows a piecing together of something, of an incident. Its ability to track pedestrians is very helpful. Its ability to sort of understand, okay, what actually happened during this traffic accident? What actually happened perhaps in a robbery? I mean, you might be able to see things like that and be, okay, it was a white, pickup truck. You're not getting license plates, but you're getting that level of extra benefit. And again, it's infinitely shareable, which is wonderful. So we can have the police department able to see some of these things without really having any concern that they could mess up our system, or we don't need to dial into their systems. So we've just been, very, very, very pleased with how this has worked. It's the scalability is wonderful. The dynamic nature of the network is wonderful. And our ability to really make a lot of these things happen and feasible is really only there because we have such a great platform. So, in Quincy, we've been delighted with it, and certainly would welcome any questions anybody might have when we're all through here.
Thank you very much, Chris. Really appreciate that. Very, very, very insightful, and we have been extremely happy with the relationship as well too, and looking forward to continuing that. So moving along here, Olivia, our traffic engineering specialist, has put together a bit of a story around some of the things that we're seeing around a stadium. So Olivia, take it away.
Thanks, Sajad. So yeah, I'm Olivia Babcock. I'm a traffic engineering specialist here at Miovision, and I took a look at what's going on with our deployments at MassDOT District 5. So next slide, thank you. Currently we have 5 intersections installed with full stacks here. And then we also have 6 intersections near Gillette Stadium in Foxborough that have yet to be installed. And then next slide, please. So the first thing that I took a look at, I was just interested because we have been installed since 2019. I was able to look at data before COVID. So I looked at the intersection of Route 1 and Route 27, both in June of 2019 and June of 2020. So on the left there, we have June of 2019. You can see we have a count of about 47,000 vehicles. And you can see that we kind of, the demand curve, we have a pretty typical commuter pattern. So we have that AM peak, kind of drops off midday and then picks up to the PM peak. And then if we switch over to June of 2020, we have a decrease in vehicles of about 9,000 down to 38,000 vehicles. And a big thing we've noticed with our COVID data is it's getting back to normal in terms of vehicle volumes, but the pattern, the traffic pattern has definitely changed. So we can see in that demand curve, we don't have as much of a defined AM and PM peak. It's kind of a gradual increase throughout the day, kind of more like a weekend curve. And then our next slide here is something that the data scientists here at Miovision put together with data across all of our installs. So this is for MassDOT 5, all of the intersections there. So this is our car, bicycle, articulated truck, and single unit truck data beginning in January all the way through to present. On the left with the blue graphs, we have counts. And then on the right, we have comparative data, and the baseline for that data is in January. So we can kind of see the brown line on each of these graphs is when the state of emergency was put in place in Massachusetts. So you can see with cars, obviously January and February holding pretty steady. And then when we get to that brown line, obviously a huge decrease and then kind of a slow increase since then. Bicycles, obviously a bit of a different story since there probably weren't many to begin with in January in Massachusetts. Obviously slow increase just as the weather has improved. And then articulated trucks and single-use trucks, kind of a similar story there between those two with pretty steady volumes, kind of unaffected by COVID. That was an essential business, so pretty steady volumes there, a bit of a decrease in April, but continued upward into June, July. Yeah. And then we get into some ATSBMs that I wanted to discuss. So just a quick refresher on this one ATSBM we call split trends. So in the bottom right corner, we have our split failure graph. So that's the one that has kind of 4 quadrants there. And then the top right, we have our split failure graph. So those are the same information, just displayed different ways. So on the left, we are just looking at how our split trend graphs are calculated. So it's using detection data. And it's either classified, or sorry, we collect information about green occupancy ratio and also red occupancy ratio after the first 5 seconds. So each cycle is classified into one of the 5 categories that we can see on the left there. So bottom left in this blue quadrant there would be low green occupancy ratio and low red occupancy ratio, so that we would classify that as spare capacity. So things are operating well, vehicles can make it through the light easily. And then just to the right of that, we have our green kind of quadrant, which shows things are operating okay. So that's kind of high green occupancy ratio. and low red occupancy ratio. And then we move to the top left, which is our yellow quadrant, which is low green occupancy ratio and high red occupancy ratio. So that could indicate random arrivals, which is usually indicative of poor coordination. And then we have our little purple quadrant there that is representative of heavy traffic. So that would be relatively high green occupancy ratio, so lots of vehicles moving through the light, and then also relatively high red occupancy ratios, so maybe the queues didn't clear. And then kind of in that extreme case is where we have very high green occupancy ratios, again, lots of vehicles moving, but then also a very high red occupancy ratio. So again, the queues aren't quite clearing, and that's what we declare as a split failure. So in the top graph, that would be the kind of PM peak there. We're seeing some significant split failures. So as an example in MassDOT, we're looking at, again, Route 1 and Route 27, that intersection. So we have two split trend graphs there. The top one is for the northbound left turning movement. We can see there's some significant split failures throughout the day, some heavy traffic as well, and then some okay operation there. And then generally what I do when I'm looking at split trends is I try to look in the opposing direction to see how that's operating, see if there's some inefficiency there, see if we can shift some green time. So in this case, I'm looking at the southbound through, and that's the second graph there. And then the pink boxes I've just kind of shown in the AM, so from about 6 a.m. to 9 a.m. We do have the possibility of maybe potentially shifting a bit of green time there. You can see in the southbound through, we do have some blue sections there, which indicates spare capacity, whereas above it in that same time period in the northbound left, there's no spare capacity. We're operating at max capacity there with quite a few split failures. So there is a possibility of shifting a bit of green time, maybe a couple of seconds there. Then just in the bottom there is actually our video feed. So I was able to go back to that date, which is August 7th, and just confirm through video what the graphs were telling me. So in the rectangle there is our northbound left movement. So this is after the northbound left was given its green, there still was 4 or 5 vehicles in the queue. So obviously a split failure there. And then at the same time, if you look in the opposing movement, that's the southbound through, there are no vehicles coming. So obviously shows a bit of inefficiency there. And then our next set of ATSPMs, just a couple more. So same movement I was looking at, northbound left, because that was kind of one of the problem movements. So this is just a longer period of time, July 13th to July 31st. So I looked at simple delay. So obviously here, the northbound left experiences up to 89 seconds of delay per 15 minutes. So that was one of the higher delay lengths for all of the movements at this intersection. And then the shaded area just represents the 95th percentile variability. So you can see how variable that is throughout the day, up to 109 seconds of delay. And then the second graph below it is green allocation. So again, another one of our ATSPMs just shows the percentage of green time given to a specific movement at an intersection. So in this case, the northbound left actually receives its most amount of green in the AM, although that appears that it's still not quite enough, but it receives 25% of the green time at around 6:45 a.m. And then it kind of slowly decreases throughout the day. Sorry, forgot you're good, thanks. And then kind of the most interesting thing I took a look at was travel times. So because we are near Gillette Stadium and we did have data from 2019 when the NFL was playing, I was able to look at some travel times on game days. So these are between 2 intersections just north of Gillette Stadium. So typically we would say southbound would be vehicles going to the game and then northbound would be vehicles leaving the game. So in the northbound, you can see that big red spike. That's actually just the AM peak of people potentially going into Boston for work. And then later in the day, we see the orange and then the green and then the red, and that's everyone that's leaving the game. And then kind of the opposite in the southbound, we kind of have smaller smaller peaks of people slowly going to the games throughout the day. And then I think my last slide is our red light runner. So this is one of our 2 safety metrics along with pedestrian compliance. The graphs look very similar and they're kind of the same concept. So in the graph, we have a yellow space, which represents our yellow light, so around 4 seconds. And then the red is anything after the yellow, so up to 10 seconds into the red light. And then each dot represents a non-compliant vehicle, so a red light running vehicle. So obviously, if the dot is in the yellow, then it went through a yellow light, and anything after the yellow, it went through a red light. So generally what I do is I'll pick a point, maybe kind of a more extreme point to kind of understand what was going on there. And then you can recall the video for up to 7 days into the past. So this was August 2nd at 8:17 p.m. So I recalled the video and I could see, you can see the red circle. It's a little bit small, but that is the vehicle going through in the northbound direction, going through the red light. And then sometimes it's hard to see in the video what's going on with the signal heads. So you can also check the telemetry at any point when you were installed at the intersection. You can go back and check the telemetry. So in this case, I checked the telemetry. The vehicle is going northbound. So obviously you can see in the telemetry at that time, the northbound had a red and actually the eastbound had a green. So fortunately, there was no vehicle at that time in the eastbound. So there was no collision, but it was a high potential situation.
Thank you so much, Olivia. That was great. So I think we're running out of time here for examples. Hopefully in another session we can go through more in-depth examples. But I'll hand it over to you, Ian.
Perfect.
Thanks to John. I guess if I come off mute, that'll be a little better. Thank you very much. That was very, very interesting. I appreciate all of the insights, both from the Miovision traffic engineering team and also Chris Cassani. That was really interesting stuff, and your whole experience through COVID of being able to instantaneously work remotely was, I'm sure, very, very enabling for your team. I'm just going to pass it back to Andrew Fonseca. He has a few final comments, and then we'll wrap it up. And really appreciate your time today. So over to you, Andrew.
Perfect. Thanks, Ian. And just to kind of echo a big thank you to all of the speakers and all of the attendees today. Chris, thank you for providing some context on how actual cities are leveraging not only the hardware, but the software and the communication. So that was great. One thing I want to mention for folks out there that are looking at ATS PMs, there is also a software only option, which is important to know, especially if you're looking at scaling. So if you're talking about you know, a DOT, for example, or a very large city that already has a ton of detection and doesn't necessarily need that portion, we can actually provide ATS PMs through a software only module, depending on the controller type, if there's a high resolution data logger on them, which the majority of the newer controllers have. There is also an option to actually just use software and for us to pull that data directly from that logger into our platform. So just broader thinking is it's from a scalability perspective, we've really thought through the options on how we could provide this data to different types of agencies, regardless of their size, or where they're at in as far as in their ITS master plan. So just wanted to drop it off there. We're at 11 o'clock now, so I just want to say again, thank you to everybody, and we'll share a recording of this video afterwards, and we look forward to hearing from anyone. If there's any questions, please feel free to reach out to Ocean State or Miovision. Thank you so much.